The third way I'm going to show you to factor is called the difference of squares. The difference of squares is just how it sounds. There are two perfect squares and they're being subtracted. So if we have a squared minus b squared, you have to take the square root of both terms and put each number into a binomial, and then your signs have to be different. So in one binomial is going to be adding, the other one's going to be subtracting. It does not matter what order you put the signs in. There's 5 questions you need to ask yourself in order to factor with difference of squares. The first thing is there a greatest common factor? That's the first thing you have to look for. If so, you need to factor out your GCF. Second question is, do you have only 2 terms? If you have 2 terms, is the first term a perfect square? Is the second term a perfect square? The last thing is there subtraction in the problem? It has to be subtraction, it cannot be addition. If you can answer these questions to be true, then you can factor using difference of perfect square. For our first example, x squared minus 25. So first thing we check is greatest common factor. There is no greatest common factor between x squared and 25, so we just have to skip that question. The next one, do we have 2 terms? Yes, we will have 2 terms, x squared and 25. Is the first term a perfect square? X squared is a perfect square. X times x is x squared, so that makes it a perfect square. 25 is a perfect square. If you take the square root of 25, you would just get 5. So that means we do have the difference of perfect squares here. So to do this problem, set up your 2 binomials. Put a plus in one, a minus in the other, and then take the square root of both terms. So first we're going to do the square root of x squared. The square root of x squared is just x. Next we're going to do the square root of 25. The square root of 25 is just 5. If we wanted to check ourselves, we would have to distribute. So distribute twice. Once again, this is just checking, this is not part of the problem. So we would do x times x is x squared. X times negative 5 is negative 5x. And then distribute the 5. 5 times x is positive 5x. 5 times negative 5 is negative 25. Combine like terms. If you have middle 2 terms, negative 5x plus 5x is 0. And we just have the negative 25 left. So after we distribute it out, it matches the same as the problem. So therefore, we factored it correctly. For our next problem, 16x squared minus 9. Go through our questions. Do we have a GCF in this problem? No. Second question, do we have 2 terms? Yes. 16x squared is one term, 9 is the other. Is the first term a perfect square? If we take the square root of 16, we get 4. If we take the square root of x squared, we get x. Is the second term a perfect square? Yes, 9. 3 times 3 is 9, so therefore we have difference of perfect squares. So your 2 binomials, plus in one, minus in the other. Then take the square root of 16x squared. Square root of 16, as I said before, is 4. The square root of x squared is x. For the second terms in our binomials, we take the square root of 9. The square root of 9 is 3. So 16x squared minus 9 factors down to the quantity of 4x plus 3 times the quantity of 4x minus 3. Example 3. Note we don't have a greatest common factor. We have 2 terms. The first term, 9x squared, is a perfect square. But the second term, 5, is not. There's not a number times itself that equals 5, so therefore I cannot factor this problem. It is not factorable. Number 4, 8x squared minus 50. Right. This one does have a greatest common factor between 8 and 50. The greatest common factor would be 2. So we're going to put a 2 on the outside and divide each term by 2, which would give me 4x squared minus 25. Right, then we need to look at the binomial inside the parentheses. It's at 2 terms. The first term, 4x squared, is a perfect square. The second term, 25, is also a perfect square. Now when you take out a GCF, you just have to leave it on the outside. And then write down your two binomials. Plus in one, minus in the other, and take the square root of both terms. Square root of 4x squared is just 2x. The square root of 25 is 5. And that's your final answer. Last example, 25a to the fourth minus 36b squared. It is 2 terms. There is not a greatest common factor because there's an a in one and b in the other. There's no common letter. There's nothing we can divide 25 and 36 by. So we need to look to see if they are perfect squares. 25 is a perfect square. A to the fourth is a perfect square. So my first term is good. My second term, 36, is a perfect square, and so is b squared. So we can factor by difference of perfect squares. Two binomials, plus in one, minus in the other, and then take the square root of both terms. Square root of 25 is 5. And when you take the square root of variables, you have to take half of their exponent. So half of a to the fourth is a squared. Then we need to look at our second term and take the square root of 36, which is 6. And then the square root of b squared. Once again, we're taking half of your exponent. Half of 2 is 1, or just 6b. So to factor by difference of squares, you can only have 2 terms. Both terms have to be perfect squares. And then to factor it, set up 2 binomials, a plus sign in one, subtraction in the other, take the square root of both terms.